we need to talk about a scheduled event on the horizon of technological history. We're talking about an impending, incredibly high-stakes shift that literally threatens the cryptographic foundation of every single digital wallet and blockchain in existence. The clock is ticking, and honestly, the stakes could not be higher.
Okay, let's dive into this. $1.7 trillion. That massive number is the amount of cryptocurrency currently secured by encryption that quantum computers will soon be able to crack wide open. It represents the entirety of the modern decentralized economy, just sitting there, resting on a mathematical foundation that is about to become completely obsolete.
Which brings us to a critical question. Is your crypto already vulnerable? It's so incredibly tempting to just brush off quantum computing as distant science fiction, right? You know, a problem for the year 2050 or something. But as we're going to see today from the absolute latest research, that assumption isn't just outdated, it's actually dangerous.
So the crucial point is understanding exactly what this event actually is. We call it Q-Day. And Q-Day is not an if, it is a mathematical certainty. It's the exact moment when a cryptographically relevant quantum computer becomes operational, instantaneously shattering the cryptographic trust that secures Bitcoin, Ethereum, and our entire global financial infrastructure. Just overnight.
Think of this as your high-stakes survival briefing. Today, we're going to cover the Q-Day extinction event, the math-breaking current cryptography, our rapidly shrinking timeline, the silent attacks happening right now, and finally, surviving all of this with qubit chain.
Let's start with Part 1, the Q-Day extinction event. We are standing right at the threshold of a totally new epoch in computer science.
And this brilliantly illustrates the immediate danger. Nearly a third of all Bitcoin, that's 6.9 million BTC, currently sits in publicly exposed addresses. That even includes Satoshi Nakamoto's original stash of 1.1 million Bitcoin. Because their public keys have already been broadcast to the network, these addresses are fully exposed. They're going to be the absolute highest value targets on Q-Day.
Moving to Part 2, the math-breaking crypto. Let's look at the specific vulnerability here.
So how exactly does this happen? Well, current blockchains rely on the elliptic curve digital signature algorithm, or ECDSA for short. Now, to classical computers, ECDSA is like thick, impenetrable vault glass. But quantum computers run something called Shor's algorithm. And instead of trying to break the glass, Shor's algorithm essentially just phases right through it, solving the complex math to derive your private key directly from your public key. The difference in sheer power here is staggering. A classical supercomputer would literally need millions of years to brute force a 256-bit ECDSA key. A quantum computer, however, doesn't just compute faster, it computes fundamentally differently. By exploiting quantum superposition and entanglement to explore vast solution spaces all at once, it can derive your private key in mere minutes.
Let's move to and see how this builds in Part 3, a rapidly shrinking timeline.
The terrifying reality is that the hardware gap is closing exponentially fast. It's like a ticking clock. In 2024, NIST finalized their post-quantum standards. By early 2026, Google proved Bitcoin's encryption is breakable with far fewer qubits than anyone originally thought, using their AlphaQubit AI to aggressively shrink the required hardware. This actually prompted Google to set a strict 2029 internal deadline to migrate their own systems, which leaves the actual Q-Day threat window wide open for the early 2030s.
These numbers are dropping like a rock. It's a massive plot twist. Previous models estimated we'd need millions of physical qubits to break Bitcoin, but in March 2026, Google showed it only takes about 1,200 logical qubits. That very same month, Caltech proved that on neutral atom hardware, you only need 10,000 to 26,000 physical qubits. With every published paper, the engineering spec for a machine that breaks Bitcoin gets simpler and cheaper.
Which brings us to Part 4, the silent harvest attack. Here is the real twist of our thriller. You don't even have to wait for Q-Day to be a victim of a quantum attack. This is because of a really insidious strategy called harvest now, decrypt later. Remember, blockchains are immutable, they're permanent. Every single time you broadcast a transaction, your public key is exposed forever. And right now, adversaries are acting like digital hoarders, patiently archiving this exposed data, just waiting for the hardware to mature so they can decrypt it all retroactively.
And for active users, the threat gets even more immediate with something called the mempool on-spend attack. Walk through this with me. Imagine you broadcast a transaction. It sits unconfirmed in the public mempool for a few seconds or minutes, right? Well, that exposes your key. A fast clock quantum computer intercepts it in real time, runs Shor's algorithm to derive your private key, and broadcast a competing transaction with a higher fee to redirect your funds to themselves. Before your original transaction even clears, your money is gone.
So, let's pivot to part 5, surviving with qubit chain. Now, what's really interesting about this is that while it sounds incredibly bleak, there is an escape pod. Qubit chain isn't just patching a leaky ship. They are building a submarine natively designed for the post-quantum era. From its very genesis block, it uses NIST-standardized post-quantum cryptography, specifically MLDSA signatures, which are mathematically immune to Shor's algorithm. It also secures the network using true quantum random number generation and this super novel proof of quantum entropy consensus mechanism.
When you compare this to legacy chains, the contrast is kind of shocking. Bitcoin and Ethereum rely on that vulnerable ECDSA math we talked about. To even attempt to fix this, they're going to require chaotic, highly contested hard forks that take years to coordinate. And frankly, waiting until the hardware exists to run a hard fork is not a strategy. It's a massive gamble. Qubit chain, on the other hand, is completely immune to the 1200 qubit threat right now. No hard forks needed because it was built quantum safe from day one.
I want to highlight this quote because it sums it up perfectly. There is no plan B when your encryption breaks. The only rational response is to migrate to quantum-safe infrastructure before the clock runs out. The window for proactive action is absolutely still open, but we have to recognize it is narrowing rapidly with every single hardware breakthrough.
So, what does this all mean for us? For Web3 developers, institutions, and individual crypto holders, it means it's time to secure your future before Q-Day actually arrives. We have to stop generating vulnerable cryptographic material and migrate to the world's first natively quantum-resistant blockchain. You can literally go join the waitlist right now over at kubichain.io.
The quantum era isn't a distant fantasy anymore. It is arriving right now. The math is completely proven, the timelines are shrinking fast, and that silent harvest has already begun. So the only question left is, will your assets be there when it does? Thanks so much for joining me on this explainer, and stay secure out there.